In this lesson, we're going to look at solving cubic and quartic inequalities. This follows on directly from the work done in A-level maths on solving quadratic inequalities. And just like with the quadratic case, it's always better to do a sketch of the graph that you are looking at first and then use that to help solve the inequality. So for each of these 5 functions that are coming up, I'd like you to pause the slide and sketch each of the graphs before unpausing and looking to see whether they're correct. Pay particularly close attention to the shape of the graphs and where they cross the x and the y axes where applicable. So this is the first one. Pause until you've sketched the curve and then unpause to look at the answer. Okay, so that is the graph for this first graph. As you can see, it's a cubic, it's a positive x cubed graph, which means it starts in the bottom left and finishes in the top right. There. And because it factorizes into 3 brackets, we can see easily 3 places where it crosses the x-axis. The x plus 4 tells us it crosses at x equals -4. The x plus 2 gives us a crossing at -2. And then the x minus 1 gives us a crossing at 1. We could also work out where it crossed the y-axis by multiplying these numbers together. So -1 times 2 times 4 would give us -8 at the end of the equation. And then substituting in x equals 0 would give us y equals -8. Okay, so the second one, again, pause this while you sketch the graph of this function and then unpause to check the graph. So this time we've got another cubic equation. It's a positive x cubed again, so it starts at the bottom left, finishes at the top right. This time we've got 3 brackets, but one is repeated. So the repeated root tells us that at x equals 4, the curve doesn't cross the x-axis, but it touches the x-axis and changes direction. We've also got a single root at x equals 2, so that tells us that the graph crosses the x-axis at 2. If we were to multiply out the numbers at the end, we would get -2 times 4 times 4, which is -32. So just off the screen here, this graph would also be crossing the y-axis at -32. Okay, graph number 3. So again, pause this for a second while you sketch it and then have a look to see whether it was correct. Okay, so there's a couple of things to notice with this one. First of all, it's going to be a cubic, but if we were to multiply this out, the x cubed term will be negative because we've got -x times x squared. So a negative x cubed graph is going to start at the top left and it's going to end at the bottom right. We've also got a root at 2, so 2 minus x gives us a root of 2. We then need to solve this other quadratic term here. So if we solve that one, that would give us two roots at 1 and -3. So if this quadratic had not had any roots, for example, if the discriminant had been less than 0, then this graph would only have crossed the x-axis once. But because it's crossing, it's got 3 roots, it's crossing in 3 places. Okay, so again, pause the slide while you sketch this graph and then unpause to have a look at your answer. Okay, so this time we've got a quartic graph. That's because the power of x is 4. So a quartic will either be W-shaped if it's a positive x to the 4, or M-shaped if it's a negative x to the 4. So this one's a positive x to the 4, which means it starts in the top left, also finishes in the top right. So it's got 4 roots, so -2, -1, +1, and +1/2. So that is the shape of the graph there. And finally, the last one, again, pause this while you sketch it and then unpause to look at the answer. So this graph is also a quartic, because if we were to multiply it out, the power of x will be x to the power 4. It's going to be a positive x to the power 4, so it will start in the top left and end in the top right. It's got two repeated roots. We've got x squared, so there's going to be a repeated root at 0. We've also got x plus 3 squared, so there's going to be another repeated root at x equals minus 3. So the graph for that one looks like this. So the graph just touches the x-axis at each of those 2 points. So we're now going to solve this inequality in 2 different ways. Both of them are going to involve graphical methods. The first one is going to involve sketching the left-hand side as a cubic, so y equals x plus 3, x minus 1, x minus 2, and then sketching the right-hand side as a linear graph, y equals 2x plus 6, and finding out where the y-coordinate of the cubic graph is less than the y-coordinate of the linear graph. So the cubic, I'm going to sketch that on a graph here. It's got 3 points of intersection with the x-axis, so minus 3, 1 and 2. Then going to sketch on the same axes the graph y equals 2x plus 6. I'm going to find where they intersect. So basically we could either multiply out the 3 brackets, change the less than sign for an equal sign, take everything over to one side, and then either solve it algebraically or use the cubic solver on the calculator. So when we solve that, where we work out the points of intersection between the cubic and the linear graph, we get 3 solutions. We get minus 3, 0, and 3. So the next thing we need to know, they're the critical values. They're the points where the 2 graphs are equal, where their y-coordinate's the same. We now need to know, where is the y-coordinate of the cubic less than the y-coordinate of the linear graph? So just look at where is the cubic below the line. And you can see it's below the line in this section here, so everywhere below minus 3, so everywhere x is less than minus 3. Then in this section between the 2 points there, so everywhere between 0 and 3. So the solution to this inequality is x is less than minus 3, and then x is greater than 0 but less than 3. So we're putting the word or in the middle of those 2 inequalities, because a number can't be both less than minus 3 and also between 0 and 3. So we're saying or to show that it has to be one section or the other. So second way to solve the same inequality, and this way takes away the need to sketch 2 different graphs, is to expand out the function on the left and then take everything over to one side, so rearrange it. So if we multiply out the left-hand side, we get x cubed minus 7x plus 6, that is less than 2x plus 6. We then take everything to one side, we get the simplified cubic x cubed minus 9x is less than 0. So we can actually factorise that left-hand side quite easily. However, if the left-hand side wouldn't factorise easily, we could use the cubic solver on the calculator, and that would find the critical values for us that way. But because x is a factor of both terms, we can factorise out the x. And then we're left with x squared minus 9, which gives us a difference of 2 squares, x minus 3x plus 3. So from there, we can see that if we were to solve that cubic, if we were to put it equal to 0, we'd get the same 3 critical values from earlier. So the intersection points would be minus 3, 0 and 3. But now we can just sketch one cubic with those 3 roots rather than having to sketch a cubic and a line. So the one cubic with those 3 roots looks like this. And now because we've rearranged the equation, we're no longer saying where is it less than 2x plus 6, we're saying where is it less than 0. So in other words, where does that cubic go below the x-axis? And we can see there are 2 sections where that happens. So the first section is here, so everywhere up to the point 0, up to the point minus 3. And the second section is everywhere from x is 0 up to x is 3. So that gives us the same solution from earlier. So the solution, we either get x is less than minus 3 or x is greater than 0 but less than 3. So just a reminder that there's also an alternative way of writing inequalities. You do need to be aware of this because it may be used in an exam, it may be used in a multiple choice, for example, or it may be used in the question itself. So in order to write inequalities in set notation, you could write it like this. So just to go through what each of the different parts mean. So we always use curly brackets when we do set notation. That just shows that the thing that we're writing inside those brackets is part of a set. We then write down what the variable actually is. So in this case it's x, but other times it might be k or another letter. We then put 2 dots and then we write down what the rule is that relates to x. So in this case, less than or equal to 3. If we wanted to do a more complicated inequality, for example, x is greater than 2 but less than 4, what that means is that there are 2 things that have to be true about x. It has to be both less than the number 4 and also greater than 2 at the same time. So because it's and, we're going to use the symbol for and in set notation. So the first set is all of the x values less than 4. We've then got the end shape, the intersection sign, and then we've got the second bracket, which is x is greater than 2. And that means that x has to satisfy both of those inequalities at the same time. And then the other type of inequality that we might need to solve is one where we've got 2 regions, for example, either x is less than 5 or x is greater than 7. So in that case, that's 2 separate areas, and a single x value can't be in both sections at once. It has to be either less than 5 or greater than 7. So that means that when we write down those 2 sets, we need to use the or symbol or the union symbol in the middle to show that it has to be either one or the other. Now can you please complete exercise 4A on page 83.